here are the solutions for the problems from 10.5. We are going to take the ratio test for a spin here. Number 11. Have the sum from k equals 1 to infinity, 3 to the k over k factorial. We might just consider what other tests we have and if anything would work here. What about the divergence test? Well, we could try to do something with limits here and see if the terms actually do go to 0. Factorials tend to grow faster than other things, so we might be confident that these terms do approach 0 and that it would have a chance. So it doesn't really offer much promise. The integral test, we don't really know how to do integrals with factorials, so that's not going to do us any good. And it's not a p-series. Also, worth noting, it's not a geometric series. The 3 to the k, that's like multiplying by another 3 every time. That part looks geometric, but the bottom is not. So I think I told you before in the notes also that when you see factorials and k's in the, or n's in the exponents, that's a good sign that the ratio test is the way to go. So let's do it. So to do the ratio test, and I'm going to be and encourage you to, when you're doing the ratio test, to say that you're doing the ratio test, just to make it clear. And always write down your limit here. So the limit as k approaches infinity of the k plus 1 term, that would be 3 to the k plus 1 over k plus 1 factorial. That's the k plus 1 term divided by the k term, 3 to the k over k factorial. And I'm not going to write it out like this too many more times because that's it just gets kind of messy. So I know that dividing by a fraction is the same as multiplying by the reciprocal, so I think in problems after this one I'll probably just immediately go to writing it like, 3 to the k plus 1 over k plus 1 factorial. I'll go right to writing it like this. I know I'm dividing by this, so that'll just flip it over. Right? And then comes the part where we have to cancel stuff out. When you're writing out your work for the ratio test, by the way, it could be, if somebody's looking to give you points for doing your work, it could be considered wrong if you leave these out. So it's really important to put those in. Here I have 3 to the k plus 1. That's 3 times itself, k plus 1 times, and 3 to the k. When I cancel these out, the only thing that's left is the 1 extra 3 on the top. And canceling out factorials, this is k times k minus 1 all the way down. And this is k plus 1 times k all the way down. So the k all the way down cancels out the k all the way down here, and all that's left is k plus 1 on the bottom. And that limit, well, highest power dominates, highest power is on the bottom, so that limit's to 0. And since this limit is less than 1, so this series converges. No idea to what it converges, but it converges. Sorry if it wasn't clear here. I did want you to do all of 11 through 15 in all of these. So if you didn't do the evens, please pause now and try this one. So number 12, we have k equals 1 to infinity, 4 to the k over k squared. And you might kind of just give that a look, see what you think about that. As you start plugging in big numbers like 3 on the bottom, 3 squared would be 9, 4 to the third would be 64. I think that these are going to grow faster. So this might not even pass the divergence test, but we'll run the ratio test anyway and see what it tells us. ratio test is not going to give you wrong information. So 4 to the k plus 1 over k plus 1 squared divided by, which is the same as multiplying by the reciprocal of this, the k term. So let's see, this is just like our 3's in the previous problem. I have one extra 4 on the top. And then here I have a k squared and a k plus 1 squared. Nothing really, I can't really cancel anything there. So I've got k squared here and k plus 1 squared on the bottom. Now, if you FOILed this out, this would be k squared plus 2k plus 1, but the important thing is the highest power of k would be just k squared in the front. So I've got k squared on the top, a k squared on the bottom, so the limit would just be the ratio of the coefficients. That's a 4 on the top and a 1 on the bottom, so that limit is 4, which is greater than 1, so this diverges. And again, I think it's important to think about what we're doing here, what the ratio test is doing. What this ratio test told us here is that as you go farther and farther out in this in this series, that's not geometric, it behaves more and more and more like a series where the ratio of the terms is 4, which means it actually does behave more and more like a geometric series as we go further and further out, and the multiplier is like 4. So that's no good, right? The whole less than 1 thing comes from what we know about geometric series. That's what the ratio test does. It's really making a comparison to see if these things behave somewhat like geometric series as you go way out. This one we could have done in the last section and say, oh, that's just a version of the harmonic series, so that diverges. But let's see what the ratio test tells us about it. Let's see, so we've got the limit, k approaches infinity, of the k plus 1 term. Be careful that you always put the k plus 1 in parentheses, right? Divided by the k term. That's the limit as k approaches infinity of 5k over 5k plus 1, or 5k plus 5. Highest power top and bottom is 5, so that's 1. And if you get a limit that's equal to 1, that is inconclusive. Now the ratio test is inconclusive there, but looking at this as a p-series, that would actually be conclusive, and that would tell us that it diverges. So the moral of this story is the ratio test is good for lots of situations, especially these ones with factorials and powers, but sometimes it gives us inconclusive when we could have known by some other result what happened. So it's a test that's good sometimes. Wasn't great there. But it didn't give us wrong information. It just said, well, by this test you can't tell. And then here we have k times 1/2 to the k. If it was just 1/2 to the k, that's a geometric series. And maybe worth mentioning that if something actually is a geometric series, that is the one kind of series at this point where we know what they converge to. We can actually say, oh, this converges to first term over 1 minus r. So, the ratio test with this. Let's see what happens when we stick that k in front. K approaches infinity. K plus 1 term, that's k plus 1 times 1/2 to the k plus 1 over the k term. So that looks like that. This limit as k approaches infinity. Here, my 1/2s cancel except for the extra 1 on the top, so I have a 1/1/2 left, and then I have k plus 1 here and k there on the bottom. So the limit here, highest power top and bottom, so that would be the ratio of the coefficients times 1/2. So that's 1/2, and that's less than 1, so that converges. Number 15. You know that factorials get really big really fast. So if you have a factorial on the top and you don't have a factorial on the bottom, you might suspect that after a little bit of experience here with these things, that if I had to guess right now, I'd say this is probably going to diverge. That's going to get a lot bigger, a lot faster. For example, 10 factorial I think is something like 3 million and change, and 10 cubed is only 1,000. So this is going to blow up. But let's see what the test looks like. So the k plus 1 term divided by the k term, which is the same as multiplying by the reciprocal. So canceling out the factorials, I have a k plus 1 on the top, and canceling these out, well, I can't really cancel those out, can I? I've got a k cubed on the top and a k plus 1 cubed on the bottom. So how do we deal with this? Well, look for the highest power. K times k cubed, there's going to be a k to the 4th on the top, and there's only going to be a k cubed on the bottom. So that's going to blow up to infinity. So this doesn't even really end up behaving like a geometric series at all, right? All of these before have turned out to be somewhat geometric, right? So that's going to diverge big time. All right, jumping up to number 21. Directions here say use any method, but I tried to pick problems that were well suited to the ratio test, so we'll see how that goes. Oh, and in 21 they're starting at 0. Not that that really matters to us, because it doesn't matter. Might think about why it doesn't matter. It's worth thinking about. So I got a factorial on the bottom, so this probably has a chance to converge. Let's do the ratio test. The limit as k approaches infinity, the k plus 1 term over k plus 1 factorial divided by the k term, same as multiplying by the reciprocal. Let's see what we have here. I got an extra 7, one extra 7 on the top, and then when I cancel out my factorials, everything k and down cancels, and I just get left with the k plus 1 on the bottom. Highest power only on the bottom, so that limit approaches 0. And 0 is less than 1, so that converges. (22). We have k equals 1 to infinity, and maybe I'll actually, you could do the ratio test on this and see what happens. I think it would be inconclusive for this, but I'm going to say here, by the limit comparison test, this behaves like just highest power 1 over k. So that's k equals 1 to infinity of that, which diverges. Because it's a p-series with p equal to 1. And I believe that the ratio test would be inconclusive there, so I think that that is the correct way to go here. So I guess I lied there when I said it's all ratio test. If you're wondering how the heck you should know what test to use, well, I think the answer is similar to how do you know what method of anti-differentiation you should use when you come up against an integral. And you're like, what am I supposed to do? Use substitution, integration by parts, what is this? And the answer, maybe an unsatisfying answer, is that you will get better with experience at knowing what to try. Sometimes you guess wrong, and you got to try again. Pick yourself up, get back in the ring. So ratio test here, for the limit as k approaches infinity. I'm doing ratio test because I see that 5 to the k. I think that's probably going to be well suited to this test. There's the k plus 1 term divided by the k term. So let's see, when you cancel here, it looks like I got an extra 5 on the bottom. And then I've got, can't really cancel these, but I can look at the highest power top and bottom, and so it's going to be a k squared on the top, 5k squared on the bottom. So that's 1/5. And that is less than 1. So this converges. 24, 25. Still left to do number 24. Ooh, look at this crazy thing. Well, you heard what I said before about them factorials. Factorials blow up in a hurry. So if you got one on the top that is not balanced out by another factorial on the bottom, this has a very good chance of blowing up. Let's see what our ratio test says. So we're going to find a limit as k approaches infinity of the k plus 1 term divided by the k term, same as multiplying by the reciprocal. Getting tired of me saying that? Well, sorry. I'm probably going to keep saying it. Now let's see what we can cancel out. Looks like I have an extra 10 on the top, an extra 3 on the bottom, and then with the factorials I have a k plus 1 left on the top after everything else cancels out. And as k goes to infinity, 10/3 times infinity plus 1, yeah, not going to happen, so that's diverging. For 25, we have k equals 1 to the infinity. I'm going to, 1 to infinity, sorry, not to the infinity. I'm going to rewrite this as k to the 50th over e to the k. I think that's going to be better that way. So, the ratio test, looking for the limit as k approaches infinity of the k plus 1 term, that's k plus 1 to the 50th over e to the k plus 1. Divided by, which is the same as multiplying by the reciprocal, the k term. So, let's see what we have here. I got two, well, I have an extra e on the bottom, right? That's 1 over e. And then here, I have a 50th degree polynomial where the highest power of k is 50, and then also highest power of k is 50 on the bottom. So this is just going to approach 1. K to the 50th, blah, 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 doesn't matter. And then K to the 50th on the bottom. So ratio of the coefficients of highest powers. So that's just going to be 1 over E. And that's less than 1. So this converges. And then what were the other two? 37 and then 43. Number 37, at K equals 0 to infinity. Not that that matters. That would matter only if we were writing out the first few terms, which is something we do sometimes. K plus 4 factorial over 4 factorial times K factorial times 4 to the K. If you got stuck on this one, or maybe you just pause here for a second and think about, what does your intuition tell you about this? Kind of a tricky one. There's a factorial top and bottom, but K plus 4, well, let's see what happens when we cancel out. And we talk about it more as we go. So the limit as K approaches infinity of the K plus 1 term. When I put K plus 1 in here, it's K plus 1 plus 4. It's going to be K plus 5 factorial over 4 factorial times K plus 1 factorial is 4 to the K plus 1. Divided by, which is the same as multiplying by the reciprocal. And up here we've got 4 factorial. That's just a constant, right? So they're going to cancel out. K factorial, 4 to the K. All right, lots of stuff to try to cancel out here. When I factor out, well, let's first of all, the 4 factorials just cancel. They just showed up top and bottom. And here I've got 1 extra 4 on the bottom. When I look at the K plus 5 factorial and the K plus 4, this is K plus 5 times K plus 4 all the way down. So the K plus 4 all the way down is going to cancel this out. I just have a K plus 5 on the top. On the bottom, I have K plus 1 all the way down, and then K on the top, which wipes out everything except for the K plus 1. So it looks like this one, I've got K plus 5 and then 4K plus 4, so highest power top and bottom ratio is 1/4, which is less than 1. So this converges. It's interesting the way that factorials behave, and I think with more practice you get more comfortable with how those cancel out. It's pretty easy with some experience. K equals 0 to infinity again here. I have K factorial and then that squared, so I'm going to actually write that out as K factorial times K factorial. That's what that means, right? And then at the bottom I have 2K factorial. I need to be careful with that. All right, let's see what our ratio test tells us. The limit as K approaches infinity. The K plus 1, it's K plus 1 factorial times K plus 1 factorial over, when I plug K plus 1 in here, the 2 distributes through that. And that, boy, is that important. That's 2K plus 2 factorial, right? I'm substituting K plus 1 in place of the K. And then I'm going to divide by the K term, which is the same as multiplying by the reciprocal. So let's see what we can do here. When I cancel out K plus 1 factorial here, K factorial here, that leaves me a K plus 1 on the top. Here, same deal, K plus 1 on the top. how about here? I have 2k, so 2k plus 1 factorial is 2k plus 2 times 2k plus 1 times 2k, and then all the way down. So the 2k factorial wipes this out, but there's two terms here because of that plus 2. So both of those are left uncancelled. And then I think what you see that we have here is this is going to be a polynomial here with a k squared front term, and this is going to be a 4k squared front term. So highest power top and bottom is k squared over 4k squared. So that limit is 1/4, which is less than 1. So that converges. And that is the ratio test. And we'll spend more time with the ratio test in the next section, and the rest of the chapter, for that matter. Which isn't entirely true. It'll go away for a couple sections, but it comes back. This is, again, the most important test that we are learning